Okay, we got to methods. At this point, you should know what a method is, so I'm not going to review that again. But in this lecture, I'm going to cover some additional details about methods. I'm going to start by explaining the concept of signature for methods. Then I'm going to talk about method overloading, which you should already be familiar with because I already talked about in the lecture about constructors. But here you're going to see another example of overloading methods which can be useful. Then I'm going to talk about 3 modifiers that we can apply to method parameters. And there are params, ref, and out. Out of these 3 modifiers, params is the only one that I consider useful. In my opinion, ref and out are bad decisions made when designing the C# language. They're code smells, and a lot of developers have the same opinion. Initially, I didn't want to include them in this course because I don't want to teach you bad things. But because I wanted my course to be comprehensive, I decided to include them here. Plus, there are areas in the .NET framework where you have to use the out modifier. So I want you to know how to use them, even though I'm not going to advise you to use out modifier when designing your classes and methods. We'll see the reasons later in this lecture. So let's get started. What is the signature of a method? The signature of a method consists of its name and the number and type of its parameters. So in this example, you see we have a point class that has a method called move. I have highlighted the areas where make up the signature of this move method with yellow. So the name and the type and number of parameters. A concept that goes hand in hand with the signature of a method is overloading. So basically overloading means having a method with the same name but different signatures. Look at this example here. We have a point class with 3 move methods. Imagine this point represents a point on the screen. And we would like to move this to a different location. So we can have 3 overloads of the move method. One that takes 2 parameters of type integer, which represent an x and y. Another overload can take a point parameter. And with this technique, we makes it easier for the consumer of this class to choose the right overload. Maybe sometimes we have 2 integers and it's more handy to call the first method here. In other times, we might have a point object and it would be easier to use the second overload. And also here we have a third overload that takes a point and a speed, which can create some kind of animation while moving the point from one location to another. You don't always have to overload your methods, but if there are cases where you see you can improve your code and make it easier for the consumer of your methods, overloading is a technique in your toolbox. Okay, now that you understand the concept of method overloading, take a look at this calculator class here. This class has at least 3 overloads for the add method. The first one takes 2 parameters, the second one takes 3 parameters, and the third one takes 4. But as you see, this is not an efficient way to overload the add method. What if you wanted to add 10 numbers together? Then we would have to overload the add method 10 times. And that's a code smell. Is there a better way to achieve this? Of course there is. The first step to make this code better is to use an array. So instead of overloading the add method 10 times, we can declare it only once and have it receive a parameter of type integer array. With this declaration, we can use the add method like the example you see here. While this works perfectly fine, there is just a slight problem here. And the problem is every time we want to pass a number of arguments to this add method, we have to create and initialize an array. So we have to use the new operator and the int array notation. It's not a big deal, but there is a simpler way to do that. And that's when we use the Params Modifier. So we can change the declaration of our add method to include the params keyword here, just before the integer array. With that, we can call this method in a couple of ways. We can use it in the traditional form, so we pass an integer array, or we can simply pass a varying number of arguments here. We don't need to create and initialize an array. And that's simpler. Again, this is not something that you use all the time, but if you have situations where your method might need a varying number of parameters, you can use the Params Modifier to make it easier for the consumer of that method to call that method. Okay, now let's take a look at the Ref Modifier. This is probably the only example in this course where I'm going to use names like my class and my method because I really don't like this kind of teaching. If you have noticed, I try to use real-world examples that make sense as opposed to abstract names like my method, my class 1, 2. It just doesn't make sense. Anyway, because the ref and out modifiers are what I call a code smell, I couldn't think of a real-world example to demonstrate this concept here. So let's just imagine this my method here takes an integer, and whatever we pass, it adds 2 to that integer. Now take a look at this example here as what we would write to call that method. Now I have a question for you. Here we have set a to 1. We call my method and pass a. What do you think would be the result of a after returning from this method? Is it going to be 3? No, it's going to be 1 because a is a value type. And that means when we pass a to a method like the one you see here, its value is being copied. So the int a that we have here is a local copy of a that will be relevant to this method here. It will not affect the original a that we had here. We can change this code by including a ref modifier to our method. And note that here I changed the name of the class and its method from my class and my method to weirdo and do a weird thing because it just is weird. So with this change, if we call this method and also include the ref modifier here, the original a that we have here will be passed to this method and its value will be modified. So after we return from this method, value of a is going to be 3. I'm completely against this concept. I think it's a code smell and I want to make sure that you're never going to use this. But if there are classes written by other people or perhaps somewhere in .NET Framework where a parameter is defined with the ref modifier, I want you to know that in order to call that method, you need to specify the ref modifier here. Honestly, I can't remember on top of my head whether we have places in the .NET Framework where methods are defined with the ref modifier. But that's all I want you to know. Now let's take a look at the out modifier. Now out modifier is slightly similar to the ref modifier in the sense that if a parameter is declared with the out modifier, as you see here, then in order for you to call that method, you also need to specify out when calling that method. But out is conceptually a little bit different from ref. What does it mean? That means with the out, this method can return a value to the caller. Now you might be wondering, couldn't we just return a value here instead of using void? Absolutely yes. But with the out keyword, we can have multiple parameters here and they all can return a value to the caller. And that's exactly where I say this is a code smell or this is a design smell of the C# language. Because if a method is going to return multiple values to the caller, it's better to encapsulate all these values into a separate class, which could be the return type of that method. So again, I want to emphasize, do not ever use the out modifier when designing your methods. But I included the out modifier here because there is one place in .NET Framework that you might be using sometimes. And that's where you have to use the out modifier, even though it's not a good choice, but I want you to be aware of that. Okay, enough theory, let's start coding and see all these concepts in action. Okay, let's start by creating a point class. So, public class point. This point represents a point on the screen. So it needs 2 fields, an x and a y, and they both have to be an integer. So public int x, public int y. And here we should create a constructor to initialize these fields. So ctor tab, we get 2 parameters, int x, int y. And this.x equals x, this.y equals y. Pretty simple. Now let's put this class in a separate file to clean up our code. So the cursor is here with resharper. We press Alt and Enter and Enter again. Now point is in a separate file. Now let's add a method to move this point to a different location. So public void move. We need 2 parameters, an x and a y. And we simply change the value of our fields using these arguments. So this.x equals x, this.y equals y. Now we can overload this method by creating another version of that takes a different signature. Maybe the other one takes a point object. Let's see how it works. So public void move. Here we pass a point object, that is the new location. And we use this object to change the value of our fields. So this.x equals new location.x. This.y equals new location.y. Now let's go to our program class. So we simply press Ctrl and Tab to switch between open windows. There you go. Let's create a point object. Var point equals new point. And I give it an x and y, so 10 and say 20. Now if we call the move method, point.move, look, we've got two versions of this method. So there are two overloads. The first one takes a point object, the second one takes an x and y. Sometimes in our program, we might just have two numbers, whereas other times we might have a point object. So by overloading this method, we make it easier for the caller of this method to pass arguments to this method. So let's try both versions. First, I pass a point object. Let's move it to 40 and 60. Now to ensure that everything is working, let's put the value of x and y on the console. So CW tab, again, this is a code snippet. If you want to learn more of these fast coding techniques, I have a course called Double Your Coding Speed on Udemy, where I teach you lots of techniques to write code fast. So here in console.writeLine, we can say point is at, and here we pass the location. So point.x, point.y. Let's run the application with Ctrl and F5. Okay, point is at location 40 and 60. So our move method is working properly. Now let's extend its example, and this time use the other overload of the move method. So point.move. This time I want to move it to 100 and 200. So I use the second overload. Again, let's copy paste this line here and make sure everything is working. We run the application. Okay, so our point is moved twice, and now it's at the location 100 and 200. So this is how overloading works. But I want to show you that there is a problem with this code in terms of best practices. Let's get back to the point class. Okay, here we are duplicating the concept of setting x and y. Now this is a very simple example, and we are just setting two fields. But sometimes in more complicated scenarios, it's not a good idea to repeat the same concept in two places. So what we can do is to make this move method call the other move method. This way, we set x and y in only one place. So if there's a bug in our program, there's one place that we have to fix. Let's see how we can implement this. So here, I simply call the other move method, and I pass new location.x and new location.y. And we can get rid of these two lines here. Looks better, doesn't it? But there's still one more problem with this code. Can you spot it? And to give you a hint, it's here. There is one tiny problem here. The problem is, if we pass a null object here, this method is going to throw an exception. Let me show you what I mean by that. So we go to program. I'm going to change this line. So instead of passing a point object, I pass null. Let's run the application. There you go. The application crashed, and we got a null reference exception. In case you are not familiar with exceptions, exceptions are .NET's way of error reporting. I've covered exceptions in full detail in my C# Advanced course that you can find on Udemy. So let's move on for now. We go back to the point class. Here we need to validate the argument that is passed in. So we make sure that it's not null. Otherwise, if we go null.x or null.y, we're going to get a null reference exception. We go if new location is null, we throw an argument null exception and pass the name of the parameter. What does this mean? First of all, throwing an exception is a way to report errors to the caller. So here, I use the throw keyword, and here I create a new exception object. An exception is just a class, and here we're just instantiating that class. And in the constructor here, I simply pass the name of the parameter that was null, in this case, new location. With this code, if new location is null, we're never going to get here. So the state of our class, which means the x and y, is not going to be changed. So this way, our point object will always stay in a valid state. The technique I have used here, as in validating this argument here, is called defensive programming, which is actually beyond the scope of this course. But basically, defensive programming improves the robustness of your code. Okay, now let's run the application and see what happens. Look, the application crashed again. But the difference is, this time we got an argument null exception as opposed to a null reference exception. So you may argue, how is it different? Well, it's better to get an argument null exception than null reference exception. Why? First of all, your application should always have a global error handling mechanism. The reason our application crashed here is because we don't have a global error handling or exception handling mechanism. I will show you how we can add that in a few seconds. But the point here is, when we get an argument null exception, we are immediately telling the caller of this method, that is this move method, that the value they have passed in is not a valid value. And as a result, no further actions will happen. That's the idea of writing robust code. If you get some invalid value, whether it's null or some value that is out of range, or maybe somewhere you don't expect a 0 or an empty string, then if you get that value and do operations on that value, you're taking your program to an unexpected state, which means some weird things may happen down the track. So the idea of defensive programming is to stop the program from getting into that weird or invalid state. Okay, now let me show you how we can improve this code by adding a global exception handling mechanism so the application won't crash. Let's get back to our program. So simply I add a try block here. You simply type try and press tab. Let me show you again. Try, tab. So again, this is a code snippet. You immediately get a try and a catch block. The code that may throw an exception should be placed in the try block. And if an exception is thrown, then this catch block will be executed. Don't worry about this throw keyword here. Just remove it. Again, I have covered the exception handling in more detail in my C# Advanced course. But just to give you some tip here, what we need to do is we simply put a message on the console saying an unexpected error occurred. Now, if we run this application, the application doesn't crash and we get a friendly error message. This is better in terms of the user experience. You don't want to write an application that crashes. No one likes that. Okay, I'm going to move all this code into a separate method. So static void use points. And I take everything here and pass it here. Okay, now let's go and create a calculator class. So public class calculator. We want to create a method called add that takes a varying number of arguments. So public int add. Here we add the params keyword, params, and then an integer array, and the name of the parameter is going to be numbers. Now inside this method, numbers is an integer array. So let's say we have an integer array and we want to add all the numbers in that array together and return the result. First, we create a variable called sum, set it to 0, and now we use a for each block to iterate over the numbers and simply add every number to the sum. And finally, we return sum. When you get to the advanced level, there is a better way to write this code, and that involves using LINQ or language integrated query. It's one of the powerful features of C#. Again, I have covered it in my C# Advanced course. So for now, let's just keep the code the way it is. Now we put this class in a separate file. So Alt and enter and enter. Now we're back to the program. Let's create an instance of the calculator. Var calculator. Now we can call the add method, like passing two numbers, and we can simply display the result on the console. Or we can pass 3 parameters, or 4, or whatever. It's up to you. You can pass a varying number of parameters, and that's the effect of the params keyword. We can also call this method using an array notation. So let me paste that again here. Instead, I can pass a new integer array and put all numbers here. But as you see, it's easier to simply pass all the parameters without the need to create an integer array. And that's why we use the params keyword. Okay, let's put this code in a separate method and move to our third example. So I'm going to create another static method here. Use params. Let's move everything here. All right, the third example involves using the out modifier. I told you, do not use the out modifier when declaring your methods, but there are cases in the .NET framework where you may have to use the out modifier. So let's see an example of that. Let's say we have a string and we would like to convert it to a number. We can use the parse method of the integer class. So type int.parse and pass an invalid string here that cannot be converted to a number. Let's store the result in the number variable and run the application. Look, the application crashed. We got an exception, a format exception. Input string was not in a correct format. Okay, now let's take a look at the try_parse method. So int.try_parse. Look, it has 2 overloads. The first one takes a few parameters. The second one takes only 2 parameters. So I'm going to use the second one. It's easier. It takes a string, and that is the string we would like to convert. It takes an integer that is decorated with the out modifier, which will have the result of conversion if successful. And finally, it returns a bool, which indicates whether the conversion was successful or not. So let's pass the string here, ABC, and here we need to pass an integer. So int number, and because it's declared with the out modifier, we need to use the out keyword here. So number, and it returns a bool. So var result. So if conversion is successful, result will be true. And we can check that and display the number on the console. Otherwise, we can say conversion failed. Let's run the application. So look, we got a message called conversion failed. Now, how is it different from the parse method? The difference is try_parse does not throw an exception. And that's the reason it returns a boolean to indicate whether the conversion was successful or not. The downside is that you have to declare this integer separately and then use the out modifier. Some people don't like the try_parse method and they prefer to use parse, but then you have to handle exception using a try-catch block, as we learned a little bit earlier. Something like this. So here we would say conversion failed. These 2 pieces of code are kind of equivalent. Now this number is actually declared somewhere else, so let me change it to just num. There you go. So here are 2 examples. I hope you enjoyed this lecture and thank you for watching.
Hi guys, Mosh here. I hope you're having a fantastic day or night wherever you are in the world. This tutorial you have been watching is actually part of one of my C# courses where you will learn everything about classes, interfaces, and object-oriented programming. In case you're interested to enroll in the full course, I've put the link for you in the video description. And if not, that's perfectly fine. Have a great day.